Good. Right now we are going to talk about the chapter number 2, which the topic is Introduction to Cisco Software Defined Access. This topic we are going deeper to what is the essential of our book. There is some subtopics that we will talk during this video. First, challenges with today's networks. Second, software-defined networking, Cisco software-defined access, network access control, introduction to Cisco Identity Services Engine, Cisco ISE design considerations, segmentation with Cisco TrustSec. 1, 2, 3, 4, 5, 6, 7 subtopics that are going to be talked deeply during this video. So, the first subtopic is a more conceptual one. It talks about the challenges with today's networks. It is very related to the last one that we saw. There is some similarities with chapter number 1. What is the main focus? Is to know that today's networks are growing, and it's not the same as it was before 10 years ago, 15 years ago. Why? Because we have many things happening. We have IoT devices that now need to be connected to our infra. We have the communication with the cloud. We have video on demand. We have a lot of data traffic inside our network. That's why our network doesn't need to be static. It should evolve, it should grow following the development of our society. There is some constraints with the old networks that we used before. One of them is the manual configuration. Go to each device to configure each device at a time, but we want to be more efficiently. We want to use better our time. That's why it comes with the software defined networking. We are already going to the second subtopic. What is the main goal of software defined networking? Well, we can think of some aspects. For example, we want to separate what is called as the control plane from the data plane. The control plane is the brain of the network. Before, each switch, each router has its own control plane to decide how to forward the traffic. But right now, they don't do the same work at the same time. We have specific devices responsible to define what is the best path that our traffic should be forward, and we have the data plane where we have the access switches. They don't think a lot because this part of the thinking and define the routes, it's done now on the control plane. And we have another one that is management plane. It's where we do the configuration. And right now, with the software defined networking, we are instead of going to each device, we have a central location that we do all the configuration of our infra, including configuration of the switches, the routers, the wireless controller, and so on. So, Cisco software defined access, the third subtopic. Well, when we look to the software defined networking, we can look in different views. We can look to the one part and we can look to the campus part. So when you talk about software defined access, it's a kind of SDN, but its goal is to focus on the campus part. Normally on the campus before we had the three tiers. Without the software defined access, we had the three tiers. We had the core, distribution, and then the access layer. But right now it's going to be more simplified, a single pane of glass to do all configuration, a separation between the control plane, the data plane, and the management plane. Okay, there is some specific terms that comes when we talk about the software defined access, because instead of having the three layers or three tier architecture, core, distribution, and access, now we have some terms that describes the role of the devices. For example, we have the border nodes, we have the edge node, and we have the control. The device that is responsible to control the device, the other ones, the control nodes. Okay, this is the three main parts of the software defined access. The border nodes is the one that do the interfaces between the fabric, the new infra, with the a node infra. We can say that the same applies with the communication with the internet, with the outside of the network. It's the responsibility of the border node. It's in the border. The edge node is normally where the users are connected. It's the one next to the user, and the control nodes are the nodes responsible for this part, the control plane. So they are the brain. They decide what is the best path to send the traffic. There is also some terms that we would like to talk when we are talking about software defined access. First of all is how is the flow, what is involved inside the Cisco software defined access. First, we want to talk about the control plane. We have the control plane, how define where the traffic will go. And in the control plane, there is a protocol that is used, that is Lisp. Location, identification, location, identification, separator, location, identifier, separation protocol. For the data plane, normally we use what is called the VXLAN. It's like an evolution of the VLAN, because we have more IDs available, and inside this packet we can have more information than we have with a normal VLAN. And the other part is the part of the policy. And the policy plane normally is done by the and the Cisco is done by the Cisco TrustSec, that we are going to talk a little bit after, no? If you see, we are going to talk on the last subject. Going to network access control is to define how to have access to our network. There is three things involved. It's talked very deeply inside the ICE. In network control access, there is the authentication server. There is the authenticator and the supplicant. Okay, when we talk about Cisco, the authentication server normally is the ICE. It's responsible to define who has and who have not access to the network. The authentication is our intermediate device, our network device. It can be a switch, it can be a router, it can be a WLC. It's what stays between the supplicant and the authentication server. So in this case, the supplicant normally is the client. So you can do a small presentation. We have here a client. We have here a server. This client, this computer, is what we call the supplicant. So the switch where we are connected normally is the authenticator, and here the server who authenticates us, who says no, this guy is allowed to have access to the network, this guy is not allowed to have access to the network, is the authentication server. And normally is done by ICE. There is some protocols that are used. Normally here we have the EAP between the supplicant and the authenticator, and here between the switch and the authentication server you have the radios. These two protocols are very important. Let's say radios and TACACs. Radios is normally used to authenticate users, and TACACs is when we want to have access to devices. What are the difference between them? Here on the TACACs, the three A's, the authentication, authorization, and accounting, is done separately. Each one, the authentication, the authorization, and the accounting is done differently. And here in the radios we have the authentication and the authorization together, only the accounting is separated. That's the difference between radios and TACACs. So radios is used to authenticate the users, and TACACs is when we want to have access to devices. Introduction to Cisco Identity Service Engine. So Cisco Identity Service Engine is able to do the AAA, the authentication, the authorization, and the accounting. Okay. And there is some features that are very important. We talk with Cisco ICE. They can do secure access from our client to the network. They can do device administration, having access to our networking devices properly. Guest access, they can deal with the portals and how you have access to the internet without being part of the company. They can do the profiling, being your own device, compliance, and integration with the PX grid. There is many things that we can talk about the ICE. We are going to pass now to some consideration of them. The ICE is organized with different nodes. We have the PAM, then we have the monitoring node, and lastly we have we have also the PSN, and we have also the PX grid controller. The PAM is the policy administration node, is where we do the configuration of our ICE. The monitoring, as the name says, it monitors the network It's from where we can have who is accessing, who's having access, who is the client, where is he going, what he is doing. The PSCN is the node responsible to ensure that the services are being delivered to the client and to the network. The PX grid is the communication between our eyes to outside devices. It can be different devices. Even with the catalyst center, the communication between the eyes and the catalyst center is done via PX grid. Cisco segmentation with TrustSec. This is the last part. The TrustSec. Before we had a problem because to segregate our network, we have to do a lot of ACLs, define VLANs, define IP addressing, and it was very complicated. So Cisco introduced a new way of doing that. It's via Cisco TrustSec. We define tags to the traffic. It doesn't need specifically to be done to the IP address. It can be the IP address, it can be the VLAN, it can be the subnet, the user according to the profile, and then we can give the right tag to devices. Then with that tag we can define what he can and what he cannot to do. There is three things that are done in TrustSec. It's the classification, define what the traffic is. After the classification there is the propagation, and there is the enforcement. Classification, we give the tags. The propagation, we propagate the tags to our network. It can be done inline and it can be done via PX grid with our devices and other brands, and the enforcement is normally done in the exit of the network. So that is what is talked in the chapter 2, Introduction to Cisco Software Defined Access.